Hey, this is Mrs. Davis. This is Calculus, AP Calculus. This is Lesson 610, Integrating with Long Division and Completing the Square. This is video 4. We're nearing the end. We have to do an improper rational function problem. So another problem like we just did. So for a little more practice with that. Let's just get started. This one uses both long division and completing the square, so a little bit of mix of both. So again, if I see something like this, I'm going to immediately say, hey, I can make that simpler by taking the quotient. So let's just do that. X squared minus 6x plus 10, all terms are there. And then I have x cubed minus 4x squared minus 2x plus 25. So all terms are there too. So x times x squared will give me an x cubed. So I have x cubed minus 6x squared plus 10x. Okay, if I subtract all that, I have a negative 4x minus a negative 6x, so that gives me a positive 2x squared. And then I have a negative 2x minus a 10x, so that'd be minus 12x. And then I'm going to bring down the 25. So now I'm saying what times x squared gives me a 2x squared, so that would just be plus a positive 2. So that would be 2x squared minus 12x plus 20. So if I subtract that, this is 0, this actually becomes 0, and I have 25 minus 20, so I have 5. So I have a remainder of 5. So it's x squared plus 2 plus 5 over x squared minus 6x plus 10. Now what you can tell before we even start is that this will be fine to integrate, this will be fine to integrate, and this is going to be one where I have to complete the square. All right, so let's go over and do the first part and get the whole integral written out with 3 pieces. So we would rewrite this as the integral of x dx plus the integral of 2 dx plus 5 times the integral of 1 over x squared minus 6x plus 10 dx. All right, so let's just do these first ones. We have integrating it, we have 1/2 x squared plus 2x, and then plus, let's just rewrite this again, and then we'll go do this. Okay, so now I'm going to go down here, and I'm going to take the integral of 1 over x squared minus 6x plus 10 dx. And this is going to be one where I'm going to complete the square, and I think we've actually even done this one, but won't hurt to do it again. That will be the integral of 1 over, and then I'm going to complete the square, x squared minus 6x plus something plus 10 minus something, and so that would be the integral of 1 over x minus 3 square, 9, right? We're going to add 9. And then 10 minus 9 is plus 1. So, wow, we're really good right here, dx. So we have to do a little u substitution. We're going to let u equal, let's see, we're going to let u equal x minus 3. So du is dx. So this integral becomes 1 over u squared plus 1 du. And when I integrate that, that becomes the inverse tan of x, x minus 3, right? And then we had a plus c for all of them. So let's go back up to where we were. We have 1/2 x squared plus 2x plus 5 times the inverse tan of x minus 3 plus c. So there we go. All right, again, that was long division and splitting it up into pieces and then doing a complete the square to get that third piece. All right, let's look at the next few examples here. They just say using long division, rewrite the integrand, and then let's actually like find them, okay, instead of just rewriting them. Okay, so we are going to divide by, oh, look, we don't have to do long division for this one because we can do synthetic, which is usually faster. So our 0 would be 2. So we have 3, -1, -5, and 1. So bring down the 3, that would be 6. 6 and -1 would be 5. That would be 10. So you get a +5, and that would be 10. So our remainder is 11. So the depressed polynomial would be 3x squared plus 5x plus 5 plus 11 over x minus 2. So that's going to be my new integral. And then those are all going to be easy to integrate. So I can just kind of do it in one piece. This would be, the first one would be 3x cubed over 3. So that'd be x cubed plus 5 halves x squared plus 5x. And then this one would be plus 11, and 1 over x minus 2 would be ln of x minus 2, and then don't forget plus c, and don't forget your absolute value. So there we have that one. Not so bad. And let's see, this one, we're going to have to use, we could use 5/3 as our 0, but I think it might be easier to use substitute. I don't know. To divide. So let's go here and divide, and then we can move to the right for our problem. So we have 3x minus 5 going into 6x to the 4th minus 7x cubed plus x squared plus 2x plus 0. All right, so the first one would be 2x cubed, right? So that would be 6x to the 4th minus 10x cubed. All right, and if we're going to subtract that, we have -7x cubed minus -10, so that would give us a positive 3x cubed, and then bring down my x squared. So now I'm looking at what I do for 3x to 3x cubed. So that would be plus x squared. So that would equal, multiplying everything through by x squared, 3x cubed minus 5x squared. All right, so subtracting that out, I get x squared minus a -5x squared. So that gives me a positive 6x squared. Bring down my 2x. So now what times 3x gives me 6x squared, so that would be plus 2x. And so that's 6x squared minus 10x, which gives me 2x minus -10x, a positive 12x, and then plus 0. So what I need for my very last term to get 12x is plus 4. Now when I do plus 4, I get 12x and then minus 20. And so if I have a 0 minus -20, I have a positive 20 remainder. All right, so our integral can be rewritten as the integral of 2x cubed dx plus the integral of x squared dx plus the integral of 2x dx plus the integral of 4 over, sorry, wrong. The 4 goes on the outside. So 4 here. And then I have, I could just write it. I keep going back here now. I'm 4. So plus 4, integral of 4 dx plus the integral of 20 over 3x minus 5 dx. There we go. All of that. All right. So I think, let's see. The only one that might need u substitution is this guy. So we'll get to him after we do all these other integrals that we can do. So the first one would be 2x cubed, so it'd be 2x to the 4th over 4. So that would be 1/2 x to the 4th, plus this would be 1/3 x cubed, that's that one, plus 2x squared over 2, so that would be x squared. That would be plus 4x, and then plus 20 times 1 over 3x minus 5 dx. So we have this last one to do. So over here, we're going to let u equal 3x minus 5. So du is 3 dx. So dx is du over 3. So we had to divide out a 3. So this becomes plus 20 over 3 integral of 1 over u du. All right, so we're ready to write the whole thing out, I believe. 1/2 x to the 4th plus 1/3 x cubed plus x squared plus 4x plus 20 over 3, and then taking the integral of that, that would be ln of u, and u is 3x minus 5 plus c. There we go. Okay. So I know that long division was longer, but it didn't make the integral any harder. All right, really quickly, these two are repeated in your notes. And so I'm going to stop the video there to save this very last one for the last video.